I think we may have got a bit of. Oh no, we didn't. We're on just chat. Great. Thought you guys might have seen some my OBS up here. Oh, it's freezing in here, dude. Cold. Ugh. Hello, everybody. How was the weekend? Mine, I've had better weekends. But it's on to a new week. So, new week of learning to code. Refreshing our memory. Oh, you guys can't see what I'm doing. Boom. So we're here now, which is apparently intermediate Python. Ain't no way this is gonna happen. Work on small projects to apply your knowledge. Consider creating a simple calculator, a to-do list, app, or basic game. I don't know if I know enough. Come on, webcam. Hey, there we go. Intermediate. I don't even. So, where are we? For a simple calculator, I would have some ideas, I guess, about like where to, and as well as the to-do list thing. Like where to kind of begin. But that'd be a whole deal. I think I want to wait to do those things. Like that's going to be a whole day. Like we're not even, like that's going to be a whole stream, right? A project. Maybe even multiple streams, depending on how in depth it is, the project. But I don't think I'm going to tackle any of those just yet. I know even on this, it's at like day 5 and 7, day 5 through 7. But like at the end of this week, I don't think we're going to be doing a calculator. So for now, we're going to do this. Dictionaries, common applications.
So now we're going to talk to
Why can't I hear this? Oh, my headset's on. There we go. Excuse me. Get some water. Okay. So, we're going to do this video. I might need to go on pause for a bit and go mess with the air because I'm freezing. Okay. Let's go.
you about one of the common applications of dictionaries, and that is making histograms. It's counting the frequency of things. And so if you think of a histogram as, it's a little graph, and there is, how many A's, how many B's, and how many C's, and there's a histogram that says, oh, there's this many of that and this many of that. And these are like buckets. These are frequencies, and this is how many times it happens. So a histogram. But we're going to do this thing where we're going to count people's names, and we're going to kind of count how many that we see. But the interesting thing that we're going to solve, just like many of the things in the computer, is we can't just sort of look at the data. We've got to look at the data iteratively, one piece of data at a time. So I'm going to give you a little problem. Okay, I'm going to show you a series of names, one at a time, and I want you to count for each name, make a little bucket, and then keep counting how many things for each of the different names. Okay, you'll notice that you have to start with one and then you move across. So just watch this and tell me what's the most common name of the set of names I'm about to show you, and how many do we see?
Oh, hold on. Let me mute this because I don't know. It's copyrighted. Okay. Ooh, oh. All right.
What was the most common name and how many times did you see it?
Zen.
That's the question. Now, here comes the reveal. So for humans, it's so much easier for you to just look at this and you think, how did my brain look at that? And you're like, okay, what is pretty common? Oh, maybe Chen is common. Oh, Chen. No. Maybe Zhen is common. 1, 2, 3, 4. Yeah. Anybody else have? Marquard's got 3. C7. And so you'll notice how our minds, without computers, we just sort of like bounce, branch and bound. We have hypotheses, and then we decide, yep, it's Zhen. That's it, and there's 4 of them. Now, how did your brain think about this as we were going through them one at a time? Well, my guess is if you really had to do this a lot, you would make a little picture like this. And then what you would do is if you saw a new name, XYZ, you'd add it to the list and give it a tick mark of 1. And then if you saw like C7 again, you'd give that a tick mark. And if you saw XYZ again, you'd make a tick mark. And then you'd keep adding to these tick marks, right? And that's how you would do it. And you wouldn't, like many of the things we do in a loop, you wouldn't really know what the most common was until the end. And then you'd sort of take a look at these numbers and you say, okay, that's the most common number. And then you'd be done. But you have to watch them one at a time. You can't just bounce around. And so that's how
mini counters with a dictionary. One common use of dictionaries is counting how often we see something. So this makes a new dictionary. C7 equals 1. I feel like it's been a long time since we've coded. My brain feels rusty. We didn't actually do anything, I think, the last stream. I think that might be adding to it. It was a rough day Friday. CCC. So there's 2 dictionaries in the mix. Print CCC. Oh. Okay. CCC C when equals CCC C when plus 1. So CC or goodness, excuse me. CSEV is 1, then this is 2 now.
We're going to use dictionaries to achieve that. Again, instinctively as humans, we just look at the stuff. But if you had a million things, you probably want to write a Python program and use dictionaries. And so this is the idea, and there's 2 basic things that happen. One is the first time you see a name, you got to say, is this name there already? If it's there already, you really just want to add 1 to it, right? That's the adding of a tick. Or you want to see for the first time, blah, 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 and give it a 1. And so you can use the name as the key. And then 1 is the value. And then first time you see Chen, you stick 1 in there. And so at this point, inside the dictionary, sort of dynamically adding it as the key. And then 1 is the value. And then and so you can use the name as the key.
Oh, okay.
And then 1 is the value. And then first time you see Chen, you stick 1 in there. And so at this point, inside the dictionary, sort of dynamically adding as soon as it sees a new name, it adds another slot in here. But then if you see the same name again, like Chen again, then you end up with a 1, add 1 to it, and so it's 2. And so at that point, Chen is 2. And so you can see how you can both extend the dictionary by encountering a new name, or adding when you see a name that you've already seen before. But then if you see the same name again,
I'm a touch confused by this.
And like Chen again, then you end up with a 1, add 1 dictionary, sort of dynamically adding as soon as it sees a new name, it adds another slot in here. Inside the dictionary, sort of dynamic, you can use the name as the key, and then 1 is the value. And then first time you see Chen, you stick 1 in there. And so at this point, inside the dictionary, sort of dynamically adding as soon as it sees a new name, it adds another slot in here. But then if you see the same name again, like
Slot
Chen,
and where?
and so at this point, inside the dictionary, sort of dynamically adding as soon as it sees a new name, it adds another slot in here.
Okay.
But then if you see the same name again, like Chen again, then you end up with a 1, add 1 to it, and so it's 2. And so at that point, Chen is 2. And so you can see how
I get it.
you can both extend the dictionary by encountering a new name, or adding when you see a name that you've already seen before. The problem
Dictionary traceback said it is an error to reference a key which is not in the dictionary. We're going to use the in operator to see if a key is in the dictionary. Creates a dictionary, print Chev. Most recent call, last. Line 1 in module. Key error, Chev. Oh, Chev and CCC false is in. It's like it's not in there. Cool.
The problem with dictionaries is, like everything in Python, there are rules about what you can and can't do. And one of the, I think, kind of frustrating things about dictionaries is that you can't just look for a key that doesn't exist. So this is a fresh, brand new dictionary. We do a constructor there, and we print out sub csev, and boom, it blows up, and that's bad. But we can solve this by the in operator. The in operator we've used in the for loops, we've used it in lists, we've used it in strings.
It's not a W. That's why it's not. I pronounce it Chev. It's not Chev. Sorry.
So
why he's using those at all? Like I don't know. But
that is a question. It's saying, is csev in CCC? Well, this is this empty one, and so it is, no, it is not. csev is not in CCC. And so using this in operator, we can avoid the traceback. We can say, if it's not there, put it in. If it is there, add 1 to it. And that leads us to this bit of code.
Wait, add
okay,
1 to it.
And that is, put it in. Not, csev is not in CCC. And so using this in operator, we can avoid the traceback. We can say, if it's not there, put it in. If it is there, add 1 to it. And that leads us to this bit of code.
Put it in.
Is not in CCC. And so using this in operator, we can avoid the traceback. We can say, if it's not there, put it in.
Okay.
If it is there, add 1 to it. And that leads us to this bit of code.
When we see a new name, when we encounter a new name, we need to add a new entry in the dictionary. If this is the second or later time we have seen the name, we simply add 1 to the count in the dictionary under that name. Dictionary, names equal csev, Chen csev, Zikian, then Chen. Okay. For name in names, oh, okay. For name in names, if name is not in the dictionary, counts name Dude. Oh, that just adds it in. If it's not there. If it's not in counts, add it in. So there's at least one. Otherwise, else, counts name equals counts name plus one. Print counts. So it's counts name equals counts name plus one. CSEV, excuse me. 1, 1, 2, 1, 2. Is how that would work, how that would run. Huh. Whew. Brain's hurting a little bit on this one. Brain counts name. Okay, so that just okay. Okay. So that just is that's what churns it through, right? So that's the brackets name equals 1. That is if it's not in there. If it is, it's gonna meaning it would skip this. It would. Oh, if it's in there already, then it would add one to it. Oh, okay. I think I'm understanding the logic. Counts name. I just practice is gonna help with this because it's like this part right here and here and here counts and then in the brackets name because it's like for loops I can do and if else's but these I'm trying to remember. So we have a dictionary called counts. If name is not in the dictionary, so does the names with the brackets that just tosses everything into the dictionary? Name not in counts. No, no, I don't think that. I think that's a list because it's starting off empty. Yeah, because it started off empty. That's just a list. Okay. I'm okay to move on. Counts. Yeah, this is just the iteration sort of thing. Counts name, so it's like CSEV, Chen, CSEV, whatever.
Okay, and that is the kind of code that we're going to build a histogram. This is going to histogram code, okay? And so this is going to have name as our iterator, names. Sorry, I made them singular and plural. That's nice, but so name is going to be CSEV, Chen, CSEV, Zhen. Now normally we'll be reading this from a file, but for now we'll keep it easy. We're going to go through this. And we're going to have counts as our dictionary. So that starts out empty, and we're going to do a simple if then else every time through the loop. If the name we're looking at is not in the dictionary already, is the key, then set it to be 1. If it's not, go get the old value, count subname, and then add 1 to it and stick it back in. So this line right here is new, adding a new thing, and this line right here is adding some things to existing things. And you do this long enough, you start with an empty one, and you do this long enough, at the very end, it will print out the histogram that you're looking for, the histogram you're looking for. And so you say, oh, we've seen CSEV twice, Zhen once, and Chen twice. And so that's the idea. And so this can run 1,000,000 times if you want. Now, this notion of
the get method for dictionaries, the pattern of checking to see if a key is already in a dictionary and assuming a default value. The pattern of checking to see if a key is already in a dictionary and assuming a default value if the key is not there. Oh, it is so common that there is a method called get that does this for us. Default value if key does not exist. Default value if key does not exist. No traceback. Default value if key does not exist. And no traceback. Okay. Name and counts. X equals counts. Name. Whoa, crud. That just blew my mind. Like, not in like a successful way. X equals counts name. X equals counts subname. Name and counts, X equals counts subname. Else X equals 0. So if name is if the name is in counts, then it puts the name in counts? Otherwise X equals 0. Okay, X equals counts dot get. What the heck? X equals counts dot get, in parentheses name. What on earth? X equals counts. I understand the dot get bit. So it gets the name and then so I can get other values. Okay. It's just that there's not a name that's not in the dictionary, so it doesn't show up, I guess.
Of checking to see if a key exists and doing one thing if it doesn't exist and doing another thing if it does exist is such a common practice that the dictionary object has this method called get that collapses these 4 lines into 1 line. And so the idea is you're going to do one thing if it's
Okay. So all these, those get smushed into here. Okay. Never mind. I made it more complicated than it needed to be.
in there, and you're going to retrieve the current thing. Otherwise, you're going to pick a default value. In this case, we'll pick 1. I mean, pick 0. This is like the default, right? Meaning what is not there. And if you say counts, now counts is a dictionary. .get, that's like string.upper, that's a method. You give it a key and then a default. And if the key exists, you get back what's in the key. If the key doesn't exist, you get the default. Okay? So, and with no traceback, this works and default. I mean, pick 0. This is like the default, right? Meaning what is not there. And if you say counts, now counts is a dictionary. .get, that's like string.upper, that's a method. You give it a key and then a default. And if the key exists, you get back what's in the key. If the key doesn't exist, you get the default. Okay? So, and with no traceback, this works. So the best way to think about this is it's in the key. If the key doesn't exist, you get the default. Okay? So, and with no traceback, this works. So the best way to think about this is those 4 lines are equal to that 1 line, because X is either going to be whatever was in there before if it exists, or it's going to be 0. Now, the nice thing about 0 is the next thing we're going to do is we're going to add 1 to it, so that's going to get us to 1. So collapsing that loop that we saw before, we can make it just a 1.
Simplified counting with get. You can use get and provide a default value of 0 when the key is not yet in the dictionary, and then just add 1. Oh, so that's a matter that accomplishes the same thing as before of like adding 1. So, or just the whole thing. It's the same way of doing the whole thing of what we just did. Counts equals dictionary names. All that credit again, excuse me. For name and names, counts equals name. So that just adds the name into, or that, yeah, equals name in the dictionary equals counts dot get. So this is the thing right here, the whole deal. Name. So it's dealing with the name. It's in the dictionary, or in relation to the dictionary, equals counts dot get name 0 plus 1. So anytime it's going to check the name. If it's not in there, it's going to add 1. Okay.
1-line loop. And this will become an idiom. This will become something that you will get used to and you will use over and over and over again. And after a while, right now you're looking at it, boy, that's a lot of syntax and semicolons and whatever. After a while, you just type this and not even think about it. It's an idiom. It's basically included in this idiom is how to both create new entries in dictionaries and update existing entries by adding 1 to them. So everything else in this is the same. Name is going to go through these 5 values, and we're going to say counts of name equals counts.get name, comma 0 plus 1. And so if, for example, this already has a 1 in it, then this is going to be 1 plus 1 becomes 2. If it's not, it's going to be 0 plus 1 equals 2. And so this is the idea of if new, set it to 1, not 0, set it to 1. Because the first time you see something, the count should be 1, not 0. It's going to be 1 plus 1 becomes 2. Counts.get name comma 0 plus 1. And so if, for example, this already has a 1 in it, then this is going to be 1 plus 1 becomes 2. If it's not, it's going to be 0 plus 1 equals 2. And so this is the idea of if new, set it to 1, not 0, set it to 1.
What?
Equals 2. And so this is the idea of if new, set it to 1, not 0, set it to 1. Because the first time you see something, the count should be 1, not 0.
Wait, what? What?
So that's why we make this default. Now the get can be used for values, and we're going to say count subname equals counts.get name, comma 0 plus 1. And so if, for example, this already has a 1 in it, then this is going to be 1 plus 1 becomes 2. If it's not, it's going to be 0 plus 1 equals 2. And so
he said that wrong.
This is the idea of if new, set it to 1, not 0, set it to 1. Because the first time you see something, the count should be 1, not 0. So that's why we make this default. Now the get can be used for anything. It just so happens that 0 is a common default because it's really common that we're using this to basically make a histogram, right? A little histogram of A, B, C, right? And so we need to make a D, but then the histogram has to start at 1. So that's basically the simplified counting with get. And, you know, there's a lot of things that we're going to do.
Wait. Oh, that's count. What's his name? Count von. Or is it just the count? I can't remember. Okay, nothing new was really added in the picture.
Inside of Python that do have to do with frequencies and how many times certain things happened, and this pattern is a really good pattern to absolutely know.
Okay. Well, the following print. Oh, I'm sorry. Well, the following code print counts. Quincy 1, Murugish 42, Bo 100, 0, 10. Excuse me. Print counts.get Chris, which is not listed. 0. Chris. It will return an error because Chris isn't in here and there's nothing in the code to add it. So, oh, we got our first one wrong. Oh. 0? Because Chris ain't in there. Okay. Huh. Oh, we have an exercise. We have his face. All right. Here we go.
So now what we're going to do is we're going to switch from just looping through strings, but instead loop through files. And it's going to take a little bit of work because we have to open the file, and we'll bring a lot of things together at this point. So.
Oh, my word. Hold on. Okay. Settle in. Writing programs or programming is a very creative and rewarding activity. You can write programs for many reasons, ranging from making your own living. What? Ranging from making your own living, okay, to solving a difficult data analysis problem, to having fun, to helping someone else solve a problem. This book assumes that everyone needs to know how to program, and that once you know how to program, you will figure out what you want to do with your newfound skills. Cool. I appreciate that. We are surrounded in our daily lives with computers ranging from laptops to cell phones. We can think of these computers as our personal assistants who can take care of many things on our behalf. The hardware in our current day computers is essentially built to built to continuously ask us the question, what would you like me to do next? Our computers are fast and have vast amounts of memory and could be very helpful to us if we only knew the language to speak to explain to the computer what we'd like it to do next. If we knew this language, we could tell the computer to do tasks on our behalf that were repetitive. Interestingly, the kinds of things computers can do best are often the kinds of things that we humans find boring and mind-numbing.
Here would be another task, and that is, here's a bunch of text from the book, and you can just split this into words and count and find out what the most common word is and how many times it occurs. So go ahead and try to do this for a second. Feel free to pause. Actually, don't bother pausing. This is too hard. We should write a program for this. It's not easy. Humans don't like this. It makes you concentrate. And so here is
Here I am just reading. Counts equals dictionary. Print, enter a line of text. Line equals input. Okay. Words equals line dot split. Okay, I get that. Print words. Words. Print counting. Dot dot dot. For word in words. Counts word equals counts dot get word 0 plus 1. So that's the counter right there. Print counts. The general pattern to count the words in a line of text is to split the line into words. Pattern to count the words in a line of text is split the line into words and loop through the words and use a dictionary to count, or to track the count of each word independently.
Counting pattern where we're going to take a line and then later we'll read this in a file. And so this is just an adaptation, improvement of the previous thing. So we're going to start with an empty dictionary. We're going to ask for a line of text and read it in. And then we're going to use split. So remember the list of words? Well, what we're going to get here is a list of words. We'll print it out and we'll run this counting. This is the little loop. For every word in whatever this was, we're going to do this idiom of either adding a new entry or adding one to an existing entry and then printing that out. So let's take a look at what we get there. So if we run this, we can give it some text, and I've got
Python word count .py. Enter line of text. The clown ran blah 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 blah. Words. Oh, so that just spells out what we just did in here. The word by word, you know what I mean? Counting, counts, and so there's and in there 3 times. On, 1, the, 7. So 7 is, or the is the winner.
Got this will be all one line, and then it splits it into words, and you see that these words here are split, 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 split. I mean, that's strings and splits. Remember, strings and lists and split. And so now the counting is going to go through this list. The clown ran after the, and it's going to build a histogram. The clown, one clown, the up, 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 these things are going to go up, right? That's this histogram. And then when it's all said and done, we end up with the histogram. And so counts is the dictionary that ends up with a histogram. And we can, so by inspection, see, oh, the is the most common word. And there are 7 of those, right? So if we sort of take a look at this.
Okay. So there's it just again? Why are we seeing the exact same thing again?
We start out, we make a dictionary, we read in a line of text, the text goes in, and then we split that and we print the words out, so these are the words, right? Then we have a for loop that's going to loop through all those things and then produce a dictionary. And when we print the dictionary out, that's what we're going to get. And the is 7, okay? So that's one line of text. That's how you walk across the words in a line of text after you've split the line into separate words. So now we're going to look at ways that you can loop through dictionaries. We just produced a loop that can build
Definite loops in dictionaries. Even though dictionaries are not stored in order, we can write a for loop that goes through all the entries in a dictionary. Actually, it goes through all of the keys in the dictionary and looks up the values. Okay. I understand that. Counts equals Chuck, Fred, Jan. Print for key and counts. Print key, counts, key. Counts subkey, excuse me.
Build a dictionary, but now we're going to look at a dictionary. And so we'll start with a very, very simple example, and then we'll work to a slightly more complex example. So here's a dictionary, just the constant. Chuck is 1, Fred's 42, and Jan's 100. And so we're going to use a definite loop with the for key and counts. Now it doesn't have to mean key, but key is a good name because these are keys and values. K, V, K, V, keys and values. I just mentally think of this as keys and values and keys and values. So this iteration variable is going to walk the keys. It's not going to walk the values. It's going to walk the keys. Chuck, Fred, Jan. Not necessarily in that particular order. As you see, it goes Jan, Chuck, Fred, because just because I typed it in this order, it's not like a list. It doesn't stay in that order. It might move around a little bit as we add data to it or as we set the data up. And so you can, in the loop, you can get the key, and so that's what prints out the Chuck, Jan, Chuck, Fred, but then you can also get the corresponding count for each one of these by just pulling it out of the array. Pulling it out of the dictionary, right? And so we can pull out the corresponding value, and so we print out Jan 100, Chuck 1, Fred 2, and that runs this loop 3 times. So if you just use the in and you give a dictionary here, remember all the different things we've been able to put there on the end of a for loop, and dictionary is another thing we can put on, and we get a list of keys. Now there's a couple of methods.
Retrieving lists of keys and values. You can... Excuse me. I don't know what's going on with my throat. You can get a list of keys, values, or items both from a dictionary. JJJ equals da 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 da. Print list. So I just prints the list straight up. Oh, but it doesn't include the values. Oh, but printing the keys is the same as printing the list? Interesting. Keys, values. Items. Oh. Cool. What is a tuple coming soon? Little teaser.
That allow us to get the keys, and so we have, we can say turn this into a list, and we get a list of the keys. So this is a dictionary, the same dictionary. We get a list of the keys. You can also get a list of the keys by using the keys method. So that's take this dictionary JJJ and give me all the keys, which gives me a list, which is kind of the same thing. And then we can ask for the values, and they give me just then the values extracted out of this dictionary. So that's nice. Now the one thing is that while I said you can't predict the order, if in 2 statements you ask for the keys and then the values, they at least come out in the same order, even though you can't necessarily predict the order that they come out. They come out in the same order. And then there is a third thing that we can do, and that is ask for the items. And we can say, give me the items. And that gives us a list. This is our first really kind of composite combined data structure where it is a list, a 3-item list, 0, 1, 2, and inside that there is what are called 2 tuples. Jan maps to 100, Chuck maps to 1, Fred maps to 42. Coming up next, we're going to have a whole chapter on that, and so just take a look at that for the moment, and we will come back to that in some detail later. This whole items idea.
Bonus. 2 iteration variables. We loop through the key value pairs in a dictionary using 2 iteration variables. Each iteration, the first variable is the key and the second variable is the corresponding value for the key. Okay. For AA, comma BBB in JJJ dot items. So items grabs the key and value. Print AAABBB? But wouldn't items already do that? I thought items already did that. Like if you were just Can this be anything and you could just do items and it would you get this
that gives us back a list of key value pairs, because it's not just a list of keys or a list of values, it's actually a list of key value pairs, allows us to write in Python a very clever and elegant loop. What we can do is actually, this items gives us back, each item in the list has a key and a value, and we can actually take 2 iteration variables. For AA, comma BBB, this is 2 iteration variables. And if you're coming from another programming language, this is super cool, and it's a Python-only feature. I've never seen another language that's capable of doing something this simple and that elegantly. So what this basically does is says, we're going to simultaneously advance these 2 iteration variables. So this is going to be the key and the value, the K and the V. Key and the value is going to be Chuck 1, then they're both going to advance. Fred, 42, Jan, 100. And so that means in this simple loop, if we just print them out, we're going to get the key value pairs, of course, in the order. And so it's sort of AAA and BBB simultaneously walk down these key value pairs. And so that's really pretty, and it makes for a very succinct loop. The syntax is a little sort of disquieting when you first see it, but it's a super elegant thing, and you just have to say items. If you don't say items, you just get the keys. If you say items, you get the key value pairs. And you have to have 2 iteration variables. If you don't have 2 iteration variables and use items, it'll complain and say, what are you doing? I'm giving you 2 things, and you don't have 2 variables to receive them. So 2 iteration variables and items are basically related.
Okay.
Now,
He answered my question.
we're going...
My issue, I should say. I want to take this moment. I'm going to pause really quick. I have to go. I'm going to go switch the laundry. Lock the front door. It's not locked right now. And maybe mess with the air. But I'll be back in a little bit. And we're back. Okay. Thank you for that. Sorry. We're all good to go there. Alrighty. And let's continue. Ooh. Yeah, I hadn't really looked at this yet. Name equals input. Enter file. Handle equals open. Name, so that opens the file. Counts equals dictionary. That makes the dictionary. For line and handle, words equals line dot split. Okay. Split. Not strip. Split. Splitting up the words. For word and words. Oh. A loop in a loop? Counts. Word equals counts dot get word 0 plus 1. Okay. Enter file to 16. What? So then there's like two different things. I think. Oh no, it's not. Wait, is it? No, it is all the same thing. Big count equals none. Big word equals none. For word count in counts.items where it grabs the. Okay, it is all the same. Okay, grabs the key, grabs value. If big count is none or count is bigger. If big count is none. Or count is bigger than big count. Okay. I understand what it accomplishes, but holy. Big count equals none. Big word equals none. For word count in counts items. If big count is none. That is the confusing part to me. Big count is none or count is greater than big count. Okay, so none is just big count. So that just includes everything then. Okay, I get it. If big count is none, which it is, or count. What the heck is count, though? What the heck is singular count? Because it's like you see counts. Oh, and counts. Okay, so count is here, and that's okay, which would be the value, right? It's bigger than big count, which of course it would be. I think. Yeah, because it wouldn't. There's no situation where it'd print where it would be 0. Because if it's in there at all, it's gonna have a 1. So we're, only worrying about what's in there. So of course it's gonna be bigger than big count, because big count is none. Big word equals word, which is this. Big count equals count. Print big word, big count. So for this one, words.txt 2 is the number, just the number, is the word used the most with 16 uses. And then in this file, the is used the most with 7 uses. Man.
To take a look. And this is code that I showed you perhaps many weeks ago about, I said this is a little story about how to read a file and count all the words in the file. And now we're back to it. And at this point, you should understand every single character of this program, every single concept of the program. You should literally stare at this and look at it, code it, play with it until you absolutely understand it. So let's take a look. Again, I showed you this weeks ago. So we're going to ask for a file name. Then we're going to open the file name. Then we're going to make an empty dictionary. Again, this is all stuff you've done before. And then we're going to have an iteration variable that's going to go through the lines in the file. Right? So line is going to go line, line, line. Then we are going to split that line, each line into words. Chop, 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 chop. So that's words is the list of the words in one line. We're inside of a loop that's going to go through all the lines. And then what we're going to do is, then we are going to split that line, each line into words. Chop, 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 chop. So that's words is the list of the words in one line. We're inside of a loop that's going to go through all the lines. And then what we're going to do, list of the words in. So that's words is the list of the words in one line. Chop, chop, chop. So that's words is the list of the words in one line. Okay. We're inside of a loop that's going to go through all the lines. And then what we're going to do is we're going to have the word iteration iterate through each word in the line. And then what we're going to do is have the word iteration iterate through each word in the line.
Okay.
And then what we're going to do is take each word in the line, and we're going to do this histogram, right? So we're going to, this is going to run not only just for every line, but for every word in every line. So we have a nested loop for every line, then we split it, and then we go across the line. So it's almost like a typewriter where we go ding, ding, and that's what we're doing. Ding.
You just know that's going to be the exercise. This has to be what the exercise is.
Ding, ding. So it's like the outer loop is going down, down, down the lines, and the inner loop is going across the words. And eventually we are going to see in this last line, every single word in the file. And we're going to do the counts get word plus one, which is our magic histogram making line that if you don't remember what that is, go back a couple of slides. I just talked about it. At this point in the code, and it's important to be able to draw these lines, at this point in the code, you have the histogram, and it's in the variable counts. Now, we want to find the largest one. Now, we have written loops that can find the largest in a list, but now we want to find the largest value in the key value pairs of a dictionary. So we're going to start with we're going to know what the largest count is and the largest word has that count, and we're going to set them both to none because we're going to prime our loop. We have to prime our loop, and we're going to say to none. And so then we're going to write one of these cool things that says for word comma count. So word and count are going to go through the key value pairs because we've got items here. So it's going to go through the key value pairs, loop through each key value, whatever it was. There could be a million words in here. We're going to go through every one. And what we're going to do is we're going to make sure that big count is the current largest count we've seen so far. And if it's none, well, then we haven't seen anything. Or the count we just read is greater than the big count so far, we are going to jump in. And this is sort of like, oh, this is a new personal best count for this particular data set. And so we're going to remember the word in big word, and we're going to remember the count in big count. So this is just a max loop. It's a maximum loop with the extra thing that we're recording in addition to what count is the largest, what the word that was associated with that count, recording it. So again, this is a starting part of the loop. We're going to do some more big count so far. We are going to jump in, and this is sort of like, oh, this is a new personal best count for this particular data set. And so we're going to remember the word in big word, and we're going to remember the count in big count. So this is just a max loop. It's a maximum loop with the extra thing that we're recording in addition to what count is the largest, what the word that was associated with that count, recording it. So again, this is a starting part of the loop. We're going to do some work, and then when we exit the bottom of this, big word is going to be the word that is the most common, and big count is the number of times. And so if we run a file, we say, oh, in that file, 2 is the most common word, and it's 16 times. If we run the clown file, well, the is the most common word in 7. And so this now and this could have a very large file and give you the most common word. And so that is sort of a really good application of dictionaries. So dictionaries are the most powerful, well, they're the most powerful collection we've seen so far. It is good to see both lists and dictionaries to understand what collections are. They are things inside of Python that can handle more than one item inside of it, and we'll learn about another collection about tuples in a second. Just understand the get method because that leads to very compact code. Understanding there are various ways to iterate through dictionaries, and so we've learned a lot. But in the next section, we will learn even more and put these together and do some sorting and do some other stuff and really start to see the real power of dictionaries.
Okay.
Hello.
24 minutes. Goodness. What will the following code print? Counts. Chuck 1, A 42. For key in counts. If counts key greater than 10. Ew. Man, this crud right here, bro. If counts So I think keys just what iterates through. Counts. So for counts, and the keys what iterates through. It's greater than 10. Ugh, I feel like they just made it complicated though. I mean, I get it. Maybe there's no way around it. I don't know. It's greater than 10. Print key counts keys. So key. It's going to be Annie, Jan, then counts key. Right? If counts key is greater than 10, print counts, which is fine. Then, oh, I'm sorry, print key, which is fine. Counts. Key. For key and counts. Would it be error though? Because we're not doing the two variable thing. Oh gosh. If it's any of these, if it's any of the answers that is not error, it'd be this one. Oh my gosh. Because this is the key. I mean, I got it right, but I almost don't feel good about it because I don't really understand it. Because for key and counts, let's bring up Visual Studio. Straight up copying this whole thing. Didn't really help a lot. Print key counts key. Counts. Counts equals. Print key. I get the print key part, so there's that. Annie Jan. And the counts. Okay, so this is the only way that my brain's understanding it, right? Bear with me. I could be wrong. Key, right? No. Okay, I just disproved myself because I was thinking the comma, right, would be like the space in here. But no, that's just the print. Wait, no. No. Okay, no, that isn't right. Wait a minute. I think I understand. For key and counts, key iterates through counts. Boom, boom, boom. Print, or if counts key is greater than 10, print the key and then so it's only if this only prints if it's greater than 10, right? So Chuck's never going to print. And then the counts key, excuse me, if it counts key, I think the variable name is what's throwing me off here. Counts. I'm so close. Print key. Counts key. So key runs through here, right? And so this is just like, this is like one thing. This is one thing. So it looks, it's like this is not greater than 10, so it moves on. This is greater than 10, print the key, which is right here. And counts key. Oh, so this is if counts key is greater than 10. My only solution is that it prints key, right, which is Annie and Jan, and then counts key, which is anything that would be greater than 10 that it picks up. So if counts keys are greater than 10, which would be 42 and 100, it would print key, which is, Annie, and then counts key, the one that was greater than 10, which is in this case 42, and this one 100. I don't know if that's right though. I feel like I'm like understanding it wrongly, even though I kind of get it. Print key. Why does it say? Okay, so keys in some ways are relevant. The name. So this just iterates through. It could say like Billy Bob, and it's like if counts Billy Bob is greater than 10, print Billy Bob, which would still be Annie Chuck, or excuse me, Annie Jan, then counts Billy Bob. So I think this does make a difference. Because it would be this. Oops, I'm sorry, this. If counts key. Does he go over this at all?
Last line, yeah, that gives us really single.
If what is it? Counts.
Concept, that's word. So ding code, say to none. Are and then what we're going to do is take each word in the line, and we're going to do this histogram, right? So we're going to this is going to run not only just for every line, but for every word in every line. So we have a nested loop for every line, then we split it, and then we go across the line. So it's almost like a typewriter where we go ding, ding, and that's what we're doing. Ding, ding, ding. So it's like the outer loop is going down, down, down the lines, and the inner loop is going across the words. And eventually we are going to see in this last line, every single word in the file. And we're going to do the counts get word plus one, which is our magic histogram making line.
So this one counts word. Oh, my brain. Hold on a second. Oh. The brackets thing, man. We're not going to do that exercise tonight. I'm just telling you right now.
Hello and welcome to
It's the brackets. Okay. I mean, worst case scenario, I talked to my dad about this because this is just. This is what we just were on. Ugh. Counts. If counts key. So I think I understand this part. Okay. I think. Oh, I hope I understand. Um, so it's my understanding that it's taking counts key as a single value in the print line here. That's why we get one here, one value here. Counts key. And here, though, it's saying if the key, like, counts as the dictionary, the key is iterating through the dictionary. So Chuck, Annie, Jan. Key's the iterator. If the iterator, boom, 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 is greater than 10, which in this case, it's all one thing, right? It's greater than 10, print the key, which it iterates through. Then comma, and then counts, key, the bit that was greater than 10 a second ago. So 42 and 11, 100. So if I just get rid of this, Annie Jan, print counts key. Aha. Counts key. Key. Ah. Okay. The fact that it's not the name that the fact that the variable name has no actual bearing is throwing me off, man. So let's just call it name. No, that has no bearing either. Iterator. So for the iterator and counts, boom, 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 boom. If counts, so if the iterator going through counts is greater than 10. Oh, are we good? Why did OBS just disconnect? Are we still live? I hope it didn't start a whole new thing. Hold on a second, folks. Y'all saw that on my screen. I need to check on this. Not that it's that big of a deal. Okay, I think we're okay. Ooh, that was weird. Uh-oh. Wait, maybe it's not live. no, we are. Weird. I don't know. But yeah. So where were we? If my hang up at this point, is well, it's not going to sit. So it takes this as one deal, right? Because this is a dictionary, and it has commas inside, so it splits it up. So this is like one deal. It's not going to have this be greater than 10. It's not going to have that. So what it is going to see is greater than 10 is this. Well, I mean, bad example, that 42. If it's iterator and counts, so this just runs it through. If counts iterator if the iterator going through counts sub iterator, I guess is how it's said, right? If counts sub iterator, if the iterator going through this or if my tongue, I tongue tied. If the iterator that's going through counts is greater than 10, which it only recognize these as being greater than 10. Print counts iterator. The iterator going through counts that would be greater than 10. Then the iterator. It's just this. Okay. Why? And I might just need to stop for tonight without knowing the answer to this question. Why doesn't it see counts iterator greater than 10? Oh, there's a 42. Then it grabs this whole thing. And for this, why can't I say, if counts iterator is greater than 10, print the iterator? And that would show the whole thing. Why? Oh, because of the key and value, huh? I kind of forgot about that. I totally forgot about that, actually. That's the thing. That's the whole deal. So the iterator just iterates through the keys. It's not the values. The iterator just iterates through the keys. That's how we get Annie Jan, because it reads the values that are greater than 10. Oh, wait. So it goes through, it iterates through counts. It iterates through the keys. And it checks the values attached to the keys. So if the values that are attached to the keys that is like currently being iterated through is greater than 10, it prints I guess in this case the iterator would just grab the key, not the value. And then the counts iterator which looks at the value counts iterator. I think I understand. I'm just making sure I do. If counts iterator it iterates through counts. So the iterator itself looks at the keys. If counts iterator, so that this part looks at the value of the keys. If counts iterator is greater than 10, pre-counts iterator so print the value that was greater than 10, and then also print just the straight iterator, which is looking at the keys. Handy Jan, because it still applies to the whole greater than 10 thing, because of this only applies if it's greater than 10. If counts iterator. So if the iterator that's iterating through counts is greater than 10. I think I understand. I think I get it. I think I just want to make sure that this looks at the value. I want to hear him say it. Need an if statement. Am I in the right one? Oops.
And iteration variable. Advance these two iterations. You get the keys. If you say items, you get the key value pairs, and you have to have two iteration variables. Every single so we're going to this.
He didn't give me a
Time out of the dictionary, right? And so in that particular order, as you see, it goes Jan, Chuck, Fred, because these are keys and values. K, V, K, V, keys and values. I just mentally think of this as keys and values and keys and values. So this iteration variable is going to walk the keys. It's not going to walk the values. It's going to walk the keys.
Yep. We know
Chuck,
that.
Fred, Jan. Not necessarily in that particular order. As you see, it goes Jan, Chuck, Fred, because just because I typed it in this order, it's not like a list. It doesn't stay in that order. It might move around a little bit as we add data to it or as we set the data up. And so you can, in the loop, you can get the key, and so that's what prints out the Jan, Chuck, Fred, but then you can also get the corresponding count for each one of these by just pulling it out of the array. Pulling it out of the dictionary, right? And so we can pull out the corresponding value, and so we print out Jan 100, Chuck 1, Fred 2, and that runs.
Okay. So that's just what does it? That's what pulls it out? Okay, I don't think that's very helpful.
Runs this. So get the corresponding count for each one of these by just pulling it out of the array. Pulling it out of the dictionary, right? And
okay. I think I just need to kind of accept that as it is. Know what I mean? Know what I mean? Because that just yoinks out the key. Then counts key. Even though it doesn't have to say counts. Just confusing as crud. Could say like items and purse, right? Like we kind of saw in the other one. It says something about purse. It's like purse items. So for items in the purse, print the item. Print item in the purse. Ooh, that kind of made it a little more confusing. Maybe I shouldn't have done that. But so that would have printed the item, right? And then how many of that item were in. The purse. Even though I shouldn't have used that. I feel like that made it worse. I'm sorry. Um, something's song on Epic. Um, so this is really. I have a feeling this is called counts just for this. Print key Annie Jan, then print how many times that's in the dictionary. What how many times? What's the count of the key? So I just need to know that. I just need to remember that's how you grab not the words, but dictionary name and the iterator. So the iterator that's going through the dictionary grabs the value of whatever thing it's iterating on at the time. Then the iterator itself just obviously grabs the iterator, or the key of the key of the item. That is okay. Iterator going through. That's how I understand it. Is understand this is the iterator is going through the dictionary. That grabs the value. Okay. That's going to do it for today. 43%. Oh, man. Tomorrow we're going to do this. We're going to spend time on this. We're going to do this. Yeah. I want to keep on with this. I want to press on. I know that we didn't do any extra proper exercises, but just pulling this up, working through it, kind of trying to chew on it mentally and try and understand it. Hold on a second. Try and understand it. Really try and learn, really. It's different. I feel like it's different learning. I mean, I say that, but I've said before, it's different learning stuff when you're older as opposed to when you're a kid in school and everything. And just the vibe is learning. You just learn all kinds of crud. When you're you can kind of settle into a rhythm when you're an adult of just not learning. You don't have to learn anything new. It's I have to learn where the grocery store is or learn where the milk is in the grocery store, but it's it's not a skill, you know what I'm saying? It's not a language. So this is I feel my brain getting more wrinkly. But it's about at this point though. There's going to be probably, I wouldn't be surprised, numerous points like this, but it's at about this point that I can kind of feel I'm feeling it now, the tug to try and pursue something else. And it's we're not even a full month in of streaming this progress, because it's I tend to have a problem with stick-to-itiveness. Not that Not that I quit, I just get interested in other things. But it's like they mean the same. I do quit things because I'm interested in something else. But it's like I'm a very ambitious guy and I like just kind of, doing stuff. And so it's like if my focus shifts, then it's like, oh, I really want to get into writing a book, making a web comic, something. Nothing wrong with those things, but it just, if I'm doing that every number of weeks, which isn't always the case, but it means I just never actually stick with anything. And I feel a bit of that now. And so I'm going to be trying to stick with this and push through it. It's crazy because it's like I feel like I'm learning a lot with this, the free Code Camp Python course, and we're not even 50% in. We're not even 50% through it. It could be a daunting thought. I don't want to think too much about that. But we'll just continue taking it day by day. I'll be honest with you. I made that like coding plan. We're probably not going to obviously abide by that, like, at all anymore. Like, we might refer back to it just to kind of see like what stuff we could do. See if it gives any good resources or anything. But as far as like the timeline goes, we're going to be on our own timeline. We're going to be absolutely be on our own timeline. Because it's like I'm in this for like, I'm in this for the win, not for like the time. You know what I'm saying? Like, I don't want to just burn through this in like 6 weeks and not learn crud, which I'm already learning stuff, so that's good. But like, I don't just want to burn through this stuff for the sake of burning through it. I want to actually ingest it and come out the other side of this thing much more knowledgeable, preferably employable, or not maybe not employable, but like a step towards being employable. And then once we get through Python, once we get through HTML, we start doing some like the Odin project or something like that. At that point, maybe we'll be employable. It's going to be a long haul. It's going to be a long road. I'm here. You got to press on, But thank you guys so much for watching today. Starting off the week with a bit of a longer stream, even though we didn't really do an exercise. We did 2 videos. Messed around a little bit with some coding on our own, but didn't do any proper exercises. But tomorrow, we got that exercise with the big video attached. So we'll do that. But leave a prayer request if you want. I'd love to be able to know how I can be praying for you guys specifically. Comment and subscribe also if you want. Love God. Love people. And I'll catch you guys in the next stream.